Assalamualaikum. Good evening, everyone. So let's start with this question. 2023 November. Okay, and it's about transformers. I want to explain about them first, but the second part of this question is asking about this. So let's start with this, with A. And let me tell you this, even if you don't know anything about transformers, even if you forgot about them, you still can answer this first part. You can get 3 marks. And so let's see. The diagram shows a step-down transformer, and the input power to this transformer is like put, as I mentioned before, even if you think you don't know, just try to put the already given information and whatever they're asking you to find, and try to connect them using one of the formula that you can find in the formula paper. So P is equal to 16 watts. Since it's watts, then I don't have to transfer it to anything. And then we have the transformer used for 2.5 hours. So we have time, 2.5 hours. Pretty much we will have to transfer this into seconds. So let's do that right now so that we don't forget it. But I'm not doing it. I'm just gonna use it later, but you can't do that, okay? And so we have the time and we have the power, and they ask us to find the energy transferred. So energy is missing. There is a formula that connects all of these. Power is actually the energy transferred over the time. But we need the energy, so what should we do? Yep, simple. E is equal to PT. And so all I have to do is just put these like this. 2.5 times 60 times 60. And you will find your answer. It is, where's my calculator? So yeah, it is 140,000 joules. Easy, right? So this is the first part, and as you could see, it's just a normal problem regarding the power. And so let's go to the second part. Explain how transformer works. And your answer include reasons for using 2 coils. So here, explain how transformers works. In your answer include reasons for using 2 coils, the iron core, and AC power supply. Before we start answering this question, let me just say what is an AC. AC is alternating current. Alternating current, which means that it is changing all the time. You know, if you're gonna draw it, it's gonna be up, then gonna be down, and then it's gonna be so strong again, and then so weak, and then so strong, like this. So it's changing, continuously changing. And here, let's get back to this so that I can explain it to you on the diagram, and try to remember these things so that we can mention them, and we have 6 marks to think about, okay? Transformers are made of 2 coils and an iron core. Now the first coil is called the primary coil. Here we have some current going, so we have a voltage that is going to let a current go through this wire. This voltage, which is called VP, trying to say that it is coming from the primary coil, and we call it the primary coil because everything is starting from here. So we have this VP, the voltage here, alternating. So it keeps on changing. If you're going to draw it, it's going to be like this. Okay, it's changing. And when we have a changing voltage causing a changing current, this changing current, alternating current, is going through this wire here. What's going to happen? This alternating current is going to produce also a continuously changing magnetic field. We know that when we have current going through a coil or a wire, this is going to produce a magnetic field around it, and this is what's going to happen. This magnetic field is going to be going there, and it is continuously changing, but it will get to this second coil here. We have a second coil around the same iron core, and then when the magnetic field, when the alternating magnetic field or continuously changing magnetic field crossing the second coil, which is called it's called secondary coil. Now what's going to happen? This is electromagnetic induction. So we will have voltage that is being induced because of the changing magnetic field. So here we have a voltage at the beginning causing a current to go through the first coil, the primary coil, and then because of the magnetic field that is producing around this coil, and then it's growing there to the point that it's going to cross the secondary coil, we will induce another voltage, another alternating voltage, because of the changing of the magnetic fields. And this can be picked from here, the output here. So input is the primary voltage, and the output is the secondary voltage. And you have to know that both of them are alternating, they're changing. And so we talked about those two. The value or the magnitude of the secondary voltage is depending on what? The primary one and the number of turns in the primary coil, because if the number of coils is high, then we will get kind of like stronger magnetic field, and then this is gonna induce a stronger secondary voltage, right? And also the number of coils in the secondary coil. So also again, if the number of turns here a little bit high, then we will have a high induced voltage, I guess. But anyway, you can make sure of what I'm saying using this formula, which is MP over VP is equal to, oh no, actually it is MP, I made a mistake. It's MP over NS equal to VP over VS. It is easy to remember. I think if I'm not wrong, maybe this one in your book it is written as MP over NS, not the capital one. But as long as you know what you're doing, then it's totally fine. Okay, so the number of turns in the primary coil over the number of turns in the secondary one is equal to the voltage in the primary coil over the voltage in the secondary one. This might be a formula for some of the problems that can come in the paper too, okay? We did not talk about the iron core. The iron core, which is like, as you may guess, it is made of iron, and iron is a magnetically soft material, which means that it can be magnetized easily, and it can lose its magnetism easily as well. And we need it to be that way. This is going to strengthen our magnetic field, the one that's going to produce here. That's why we use an easily magnetized material. And also, we have to know one thing to know about is step down and step up transformers. But before that, let me just make sure that we covered everything here. So we talked about the two coils. Yes, we did. We talked about the iron core. Yes, I did. The alternating power supply. Yeah, why does it have to be alternating? Because the magnetic field that is going to be produced because of the current around the primary coil, it has to be changing in order for the magnetic field to be changing so that it can cross the secondary coil and induced a change in magnetic, change in voltage. I hope you're following with me. You can read from the book, and I believe it's going to be clear, more clear now. I hope so. So let's get to C. C is saying like state how the primary coil of the transformer can be changed to increase the output voltage. So they're saying the primary coil of the transformer can be changed. Here, let me clean it a little bit for you. So how can I make any kind of change in this part so that I can make the output, which means Vs, can I make it a little bit stronger? And I just explained that when I was talking about the transformers. All I have to do is, can you guess? There is a way to make it stronger, this one stronger, is by having more turns here. If you have more turns, this part, then Vs is going to be stronger. But the question is asking about this part, about the primary part. So what can I do? All I have to do is just have less turns here. Like if you have less turns here, then the voltage, the output is going to be stronger than the input. So the number of turns, they affect the voltage right away. If you have the number of turns at the primary coil greater than the number of turns in the secondary one, this one as it's shown in the original one, let me have it again, then this is saying like the number here are bigger and then they're gonna go down. This is a step down transformer, which means that we have a high voltage, but because the secondary part is having less turns, then we will end up having less voltage as its output. It's less strong. Tamam? But if you make some kind of change and your transformer is the opposite of what's showing, we have this transformer here. As usual, I'm so good at drawing. So here you have it like a little bit, 4 or so turns, but here you have a lot of turns, which means that MP is less than NS, the number of turns in the primary coil is less than the number of turns in the secondary one. This will cause the voltage here is small, Vp. So here, because we have a lot of turns, it's gonna go up. Vs is going to be stronger than Vp. Vp, which means that Vp is less than Vs. And so all I have to do here is make primary coil has less turns. Less turns. Yep, I think that's it for this question.